Hi everyone, this is Anurag. I'm one of the co-founders at TrueFoundry, where we are building a platform to help companies operationalize their ML models in a reliable and scalable manner. Today we have Sheekha with us, who is the director at data science at Simpl. Simpl is building India's leading first tap checkout network, where they provide merchants with an entire set of products, starting from BNPL to helping them pay in installments to a lot of other value-adding services. They work with more than 26,000 merchants across India, including Geo Platforms, which is the largest telecom network, Zomato, which is one of the biggest food delivery service in the country, and a lot more. Thanks, Sika, for deciding to join us in this. And it will be great if we can start with a brief introduction about yourself and what you look at data science function at Simpl.
Thanks, Anurag. I'm really looking forward to have a nice chat. As you shared, I serve as Senior Director Data Science at Simpl. Simpl, you've already shared, we offer a one-tap checkout network, entire checkout experience to merchant, and we have a lot of apart from the usual checkout options, we have a lot of other support services which is aimed at helping merchant convert their customers. What I specifically look at is because we have a suite of products on BNPL and pay in installments, and we also provide certain risk metrics around cash and delivery. All the transactions goes through the data science systems, where we invest very heavily into our anti-fraud systems, because also there is some sort of a underwriting involved, because all users cannot see some of our BNPL options. So the underwriting team and other support team, for example, our collections teams and support team and marketing team, we work with them to help them deliver some value where data science can come in.
Amazing. Great to hear. This is probably our first fintech company that we are talking to, so it's a pleasure to know about the use cases. Sika, it might be great if we can start with the overall value chain for different ML use cases within Simpl's platform. So if you can walk us through from a user perspective as to what the platform offers to its merchants, and where does data science play in, and why does it become so important, like in a country like India, as you mentioned about underwriting. So it would be great to dive into that a little bit.
Sure. Yeah. So let's say you're a D2C merchant, right? Smaller merchants. And for a merchant, one of the harder problem is to get conversion. You'll have a lot of people browsing to your website, adding things on your cart, but because the trust is missing, like the customer doesn't know about you, so they're not very sure they want to use their card on your network, you'll find that the conversion rates are very, very low, right? And this is one of the use cases we want to support the merchant. So if they integrate with us, we provide the entire suite of, you can pay by credit card, debit card, cash on delivery, and also you can use simple sign-on option and get the simple buy now pay later option, or pay in 3 installments available to you, right? So with these two options from Simpl, we've usually seen higher sort of conversion rates, just because of the trust factor, right? I'm going to pay from my account to you after a time, probably when I have received the product, right? I also don't have to share my credit card details with you. I'm just sharing my Simpl account with you, right? And so money is actually not going in from my account. No hard cash is going, right? So that helps build the trust for the user. So that's one point. And for the merchant, another problem, and that's why cash on delivery is so big in India. If you move outside the tier one towns, right, it's one of the biggest drivers in India. For the merchant, it's also one where there's a lot of risk, because of RTO, return to origin, right? So we also provide them with some intelligence that this particular order can have a high risk of RTO, and the merchant can choose to offer COD at that point in time or not, right? So these are different use cases that we have. And then we are also building on a use case, because for a small merchant, it's very hard for them to, let's say, apart from their core business, invest onto building a great support team, or other services. So using Simple Sign On, we help Simple customers raise support tickets with Simpl itself, and we help it resolve with the merchant, right? So all of that is the overall use case. Now, where our team comes in is because we have to be very careful around fraud, right? Like if there is a loophole, you can lose a lot of money, and then you won't be able to serve your good customers, right? Because you're offering products like buy now, pay later, and pay in 3 installments, and offering a risk assessment on COD, right? So every transactions goes through our system, all of it, every single one of them, right? And we can choose to say, okay, this customer, I am not gonna allow a buy now pay later transaction for this particular customer because I see some high risk metrics. It could be an account takeover cases, identity theft, or something associated that we have identified, right? So and that system that we run is not a one machine learning system or a one model system, right? It's comprises of very simple rules and filters to machine learning model to even neural network systems that we have deployed at real time to sort of make that decision, right? That's one. The other use cases that we have is for some of our products, which is paying 3 installments and others, right? We need the user to provide us some onboarding data, and that's when we say, okay, this user would probably be allowed to shop for X amount of rupees in a 15-day cycle or a 1 month cycle versus someone with a Y amount of rupees. What is that amount of rupees that you're comfortable initially giving a user? So that underwriting bit also comes into place where our teams are involved, right? A lot of that used to be bad jobs, but now we're moving towards more and more real-time pipelines and systems coming in. Yeah. And then let's say there is a customer for whom the pay later product, they've not paid on time, right? Unfortunately,
Mhm.
they've not paid. And could be multiple reasons. You forgot,
Sure.
you circumstances changed, and it's difficult circumstances for you, not able to pay and all of that. So we want to work with that customer to figure out what's the best way forward, which works for both of us, right? Maybe have a paying parts kind of a thing. Maybe give them, it's just a forgot, so give them a reminder or something like that. So that's
Sure.
all of these places where our team comes in.
Amazing. So basically, I read it as three major parts. One is like at the point of transaction for fraud detection. The
Yes.
second is at the underwriting layer, and then is even at the collections layer, right? Like that's great to hear. So would love to kind of dive a little bit into how big is the current data science team, including the entire engineering that supports it, and like how is it structured into data scientists, data engineers, slash ML engineers, and the infra team. And when did you start on this journey as well?
Cool. So it's been more than 2 years for me at Simpl. Before that, I was with another fintech firm. And currently, our team is 28 data scientists and 16 data engineers. We have a separate DevOps team. Um, the data team, which comprises of data science and data engineering, it's a core team at Simpl, along with other engineering teams. Uh, right. So yeah, that's the current size right now. Like I said, because of our heavy investment in anti-fraud, a lot of team is working on that, not just the systems that I just talked about, the ML, the neural network system, and the rules. We also are working on a graph database and coming up with graph machine learning models to sort of look
Mhm.
at communities of fraud users, right? Because one is one transaction was a fraud, the other is that you were hit by organized fraud, right? Those are two separate use cases.
And do you see this organized fraud instances happening in India, and is it very specific to India, or how do you kind of compare it to, say, when you look at other fintech organizations across the world?
Oh, fraud is a big industry. Like people, I mean, it's a proper organized industry, and we lose millions and millions on fraud, right? Not just in India, across, right? And people run call centers. You'll be amazed at how sophisticated fraud can be, especially when it comes to organized fraud, right? The mule account problem. There are YouTube videos which tells you how to defraud, and I'm not joking about it. Like I have a person, we have a manual monitoring team as well for transactions, right? And one person there is tasked every week to just go and figure out what's there out in the internet around
Wow.
these things, right? Yeah, it's amazing. People run IVR calls. OTP phishing is sort of very, very high, very big in India. So yeah, it's very creative. It's fast moving. It's like an amoeba, so it changes very fast. So you really have to be on your toes. So it's
Amazing.
fun work. It's really fun work working on anti-fraud.
Nice. Nice. So I think the ML use case as well as the business implication is clear for the fraud side and maybe the credit underwriting side. I'd love to hear maybe on the collection side, is that something, an area you have recently invested in? What has data science created from a business impact perspective in that zone before we dive into the more technical details of this stack and others?
Sure. Yeah. So collections, yes, collections is our most recent foray, but we have built systems there. Most importantly, what we built, right? When you go out into collections, you have very broadly, very like top of bird eye view, three kind of customers, right? One is maybe forgetful, did not remember, that kind of a customer.
Okay.
You don't want to spam that customer with
Sure.
multiple calls, right? You don't want to do that.
Sure.
There is this third kind of customer you call, let's say second kind of customer, you call 1,000 times, they will, they've decided not to pay you. They just, you know,
Okay.
they don't want to. Could be multiple reasons.
Sure.
They will claim they didn't do the transaction, so identity theft, account takeover, or fraud cases, right? And then there's this third kind where they need certain push from you, maybe a call from you, maybe a different sort of a product or different payment plan, or the fines are big, or maybe they have a support ticket unresolved that you need to work with. And we have an in-house collections team. Now you want to get the biggest bang for money, right? So where you invest your calling team's efforts on. You don't want to
Sure.
invest in the first and the second group. You just want to focus on that core group from where we'll get most of the money back. So this is what we've tried doing. We built a unsupervised learning algorithm which sort of gave these three classifications. We were able to focus our efforts where we were able to collect faster, and we were able to collect more. So we've seen that, and we are improvising on it even now. So yeah.
Nice. That's great to know, and it's good to hear that Simpl invested very early in the journey, because it becomes like almost an important part of the business mode that you all are building. So
Yeah, yeah,
great to
yeah.
hear.
You can't scale your calling team with the business, right? Like we've grown so much, you can't just add people and just add on to the cost, right? You have to, that has to be a fixed cost that is there and it's not increasing.
Nice, amazing, cool. Sika, let's dive into a little bit about when you started the journey and how it has evolved in terms of the tech stack.
Right.
From a current tech stack perspective, what does the entire workflow look like from, say, an experimentation perspective to demoing perspective to deployment to monitoring? Would love to hear, and which kind of tools and technologies come into the interplay there.
Right, sure. So we are just on one cloud. We don't have anything on prem. Like everything is on cloud, and we've grown a lot over the last 1.5 years. Like earlier when I joined, most of our system were batch systems, right? And we would have, so there's a data scientist, and we had a very small data science team at that point in time. We would do our analysis, because analysis and EDA, right? Exploring data is the first and the most important crucial piece, right? So we had a remote machine on which we had Python notebook, where we had connectors, libraries built in by a data engineering team, which would connect to our databases, and you could do EDA there, and you would analyze there, and okay, this is the problem statement. Let's say you're building your own simple score that we currently have, right? That was one of the projects that we started on. So you did the analysis, you figure out, okay, these features are important, the usual, right? Like you did weight of
Mhm.
evidence, all of that, the usual thing. And okay, now this is fine, you're going to build the model. So all of that would happen just on that PyConsole. And then uh, we would set up a pipeline with the engineering team help. And even our data scientist, if it's a batch model, can deploy end to end, right?
Sure.
And we had very basic structure. So we would have, like I said, it was a batch model. We would use Airflow for scheduling. So it would,
Okay.
right, it's running, let's say, once a day or 3 times a day. We have an Airflow job, which is scheduled through
Mhm.
that. But we would replicate all of that effort for the training pipeline, because training schedule is different, right? So you have a code base in a repo where your model is deployed. Model is saved as a pickle file in an S3, and all of that, right? And then you replicate all of that effort, build the pipeline again to have your training pipeline, and then schedule it at a certain interval, once a month, once 15 days, whatever is required. So that was
Okay.
duplication of effort. That's still there, right?
Okay.
And in terms of model monitoring, or in terms of um, we just had simple dashboards looking at how the output is changing, right?
Mhm.
There is not very uh, uh, now is it that we have started investing into ML ops, but earlier there wasn't much. So a population drift, very simple. You're looking at PSI scores and CSI scores. Has it changed?
Okay.
You're looking at rank ordering of your different scores and stuff like that to see if there's anything off or anything different. And then you go back and say, okay, now it's time for probably looking at the model again, doing a refresh again of it. So yeah, that was a basic batch deployed system mostly. On the anti-fraud side, batch won't work, right? So we did have a system where we had a lot of batch systems, like we have, look at similar email IDs. You'll be surprised to see like how people can get. We had a use case, and this came up from a fraud that we detected. We had someone who would come up with 15 different phone numbers, sign up with that, and in the email they would just change the dot from one place to another.
Okay.
It was a G. Yeah,
Interesting.
exactly. Exactly. You can add plus sign to it at the end, it'll go to your same email, right? And all of those usual things. So we came up with an ML model, but the amount of data that we had to crunch, it couldn't run real time, so it was running its batch. Right. And
Got
similarly,
it.
we have simple rules that we could have at run at real time. That was there, right? Around how amount you're transacting in velocity and stuff like that. Very simple rules. So those were deployed at real time, but we didn't have anything fancy. Last year is when we deployed a neural network model, which is looking at the payload at that time and then combining historical data of last 1 year, pushing it to a neural net model, getting output, and then deciding whether to allow the transaction or decline the transaction, right? That was
Okay.
a big project on our part, and we had, and kudos to our data engineering team where it was more work for them. Because for us,
Okay.
the frameworks are so mature now that training a model is not really a big deal, right? Like
Sure.
you have such advanced libraries on Python, which was not
Yeah.
available 10 years back. It's not that big a deal, right? The data engineering team built a Flink pipeline here, um,
Okay. Interesting.
to combine the current payload with the historical one, get the output, and
Mhm.
uh, and here, yeah, our SLAs are very very low. Like it's like 70-80 milliseconds,
Got
and
it.
to manage our peak traffic in that SLA was not an easy task. Like when we initially deployed it, there we found that for 50% of the times, we were almost 40 to 50% we were timing out. Then we put in a lot of effort to reduce that,
Okay.
and yeah, I think it was one interesting project. We had a lot of learning in that.
Interesting. So, let's start with maybe the data side. So, so you use Flink pipelines. Do you use anything from a feature source perspective, or is there you know, uh, is there a movement towards kind of building an internal feature store using some of this? Would love to hear a little bit about that.
So for some of the models where we need to save like these feature stores that needs to be available at real time, we usually use DynamoDB right now, but that's expensive.
Okay.
Uh, and so there is efforts into building a feature store and exploration around that.
Okay.
Um, because right now we have, yeah, um, you also want to bring out down the cost in the long term, right? Like I said, DynamoDB is very expensive. The reads and writes are expensive.
Got it. Got it. And then suppose this data is stored in different databases, the ML team that is doing the training,
Hmm.
what is the volumes of data that they deal with? Is it in terabytes? Is it in GBs? And do they need to use virtual machines for their training jobs, or do they run it on local machines?
No, nothing is on local. It's virtual machine and it's in terabytes. It's like a lot. It's huge
Got
amount
it.
of data. Yeah.
Got it. And how do you then manage the cost of provisioning these virtual machines, or who does the provisioning? Would love to hear a little bit about that.
Mostly it's DevOps team that we work with
Mhm.
along with our data engineering team. We do have a lot of on-spot instances as well for some of these non-critical tasks.
Okay.
Uh, I unfortunately am not very, it's not my core domain area. Like I have
Sure.
mostly been like, we need this. And
Okay.
my team, DevOps and data engineering, is usually the one who will figure out the best and the most cost effective option for us. So I
Got
can't
it.
probably go more on the tech side of it. But yeah, this is an area definitely that we want to explore more, and we are, right? Because some of these models are not cheap; they are expensive, so they have to recover the cost of you actually putting out the model, right? And we do that, like what's your fixed cost, what's your costs that'll come out, like, and how much you're going to save and all of that, because you're going to save these many amount of people. At what
Mhm.
threshold are you going to save how much at the cost of good users as well, right? There's a precision recall uh, balance that you have to maintain as well, right? So yes,
Very good.
my team, as we talk, the DevOps team, one of the targets is to reduce the cost, and we are exploring few things.
Mhm.
uh, when we initially started, at that point we were like, okay, let's first get the system up, we will figure out the cost later. uh,
Okay, got it. So, but cost is an important parameter that goes into when you are kind of.
Absolutely.
Okay, got it.
Yeah, and when you're scaling, right? Like this is not just one system that you'll have. You will be replicating so many more of it. You can't just have the cost linearly go up, right?
Got it.
It's
Got
an
it.
important design constraint for us. And now it's very ingrained.
Right. Do you have a visibility into whether how is the uh, interaction from the DevOps to the data science? Because as the ask for machines comes, like is it like automated for them, or do they have to go ask and then provision? So is there like a time lag and uh, bit-
There is at least 3 days.
okay,
That is what our DevOps team tell us, because they have multiple requests, not just from data team, multiple teams, right? So at least 3 days, right? And we when we plan for a project, when we plan for a deployment, we take that into account that hey, we'll be working with DevOps team. They say 3 days. Usually we get it before, but I mean, if it's an urgent request, I know if I tell them, I will get it, but then they will not consider the cost. If they have to consider the cost, think about it, they will brainstorm with our data engineering team, come up with it. It will be 2 to 3 days, right, to get that
got it.
provisioned.
Got it. Understood. And you mentioned about the training pipeline running separately from the comparatively the inference pipeline. Like, what is the reason for that? Like, because ideally you can just have like a process that kind of schedules two different versions at different times, but you don't have to replicate and manage those two pipelines separately. So, I would like to understand, like, is that a constraint of the current system, or would like to understand that a little bit.
I don't think so. It's a constraint of the current system because now we are going towards that. Um, it's more like how it was designed. So when we started some of these systems, we were a very small startup, and
Mhm.
we had just one connector to, let's say, Redshift, right? And the queries were also not very optimized. So we deployed it, and then you were like, okay, now this is doing fine, now let's build the training pipeline. And this was just one way they decided. So we have a training pipeline that's built and is being used again and again, right? Like that. So for example, like the scripts that is used to generate the model, right? We don't,
Mhm.
the logging is also not very detailed, it's not complete, right? So it makes it very hard for even the primary owners who created that to recreate that exactly, right?
I see.
Because currently the work is happening on this Jupyter notebook. There are intermediate static files which are generated ad hoc in the notebook, right? And we don't
Right.
trace them later on, right? So all of these were issues. So it was like, okay, we did the prediction pipeline. Now we need to build training pipeline because we've observed it. Now it needs to be retrained. So now people go build it all over. They're not touching the production system at all.
Okay.
It's
Interesting.
more like that. Yeah.
Okay.
And that led to mushrooming of some of the problems which are common in startups, right? It's hard to track your models origins. It's what are the training matrices, right? It's very hard for you to in case of model evaluation retraining, the codes are, because they are written separately,
Yeah.
it's possible that there could be errors, right? It's not exactly replicated. So those things in our reviews we try to be very careful, but human
Right.
error is common, right?
Sure. Sure. So ideally, you'd want to be at a state where this pipelines are merged, right? Like, and the retraining.
Yeah,
Got it.
because you've already written a pipeline where you're pulling your data for, you can
Yeah.
just reuse.
Yeah. Sure. And the retraining right now is manual, or is it kind of automated? Like you have set alerts, key, okay, metrics. Like you mentioned about some of the metrics. So, like those metrics automatically re-trigger, or do you kind of have to do it manually?
No, we right now for all the batch systems that automated at a specific interval we have set, let's say once a month or once 15 days or something like that, right? For some of the newer systems that we have built, especially this neural network model, because of the amount of data, and we couldn't use so much of that on the remote machine that we have, because 28 people logging onto that machine, and if one person loads so much data, it
Yeah.
just crashes. So we were using SageMaker for it, and unfortunately that doesn't have a pipeline. So that training is right now manual. We are automating it right now as we speak.
Okay, interesting. So
Yeah,
you
yeah,
mentioned SageMaker that you use. Do you end up using SageMaker notebooks for your
yeah,
the training? Oh, okay, okay.
yeah,
And
we
how
use
has the
Sage.
experience been there? Like what are some of the things that versus using say a Jupyter notebook versus using SageMaker notebooks, and what are some of the things you'd further like from a data science perspective? It would be great to hear that.
Right. So SageMaker, it can handle a lot more data. Like it's more mature for sure. But one of the biggest problem with SageMaker is, so 15 people log on to SageMaker at the same time. If I load something big enough, it crashes for everyone. It's not that it's you create those, user level max, and it crashes only for you, right?
Got it. Interesting. So basically, the resource allocation to one person affects everyone else, and
Correct.
then and
Correct.
who manages this entire SageMaker? Like, because I think SageMaker is runs separately from the infra team, so it's completely managed internally within the ML team. I'm guessing, or
Yeah. So DevOps team is there, but we have one person dedicated for the data engineering team who works with the data engineering team, so like an ML engineer.
got it.
And we do have regular issues of it crashing and all of that, the usual, right? Like, so that's
Got it.
that's where we decided that it's time for us to build a SageMaker like system where we, these problems we can manage at our end. So that's also something that is work in progress for us.
Interesting, interesting. And one curious question, like you mentioned, SageMaker. So I'm assuming you are using AWS. So in AWS, like you can choose to kind of also use like the EC2 machines for deployment, or you can use like basically the EKS. Like, did you ever consider going the route of using Kubernetes based system? And what were some of the challenges that led you to maybe adopting SageMaker initially?
So we did use, we have used EC2 machines. We
Okay,
still use that. We've not tried Kubernetes. We've
got
had engineers who have really wanted to try it, but I think for some reason, I don't know why we have not tried it yet. But that doesn't mean we'll not try it.
got
And the reason for using SageMaker was, when we were appointed, we were like 5, 6 people, right? When I joined, we were 4 people in data science team. So we were appointed the 6, 7, and we were getting issues with PyConsole and all of that. We were like, let's try it out, right? Everybody is using it, let's try it out. So that's how it just started off as an experiment, and we realized it was much faster than our current system was. Um, and so, yeah, for some of our projects, it worked well.
Got it. Got it. Understood. And given you use huge, terabytes of data, do you end up having to train on GPUs, or currently like the CPUs tend to be sufficient?
No,
Uh,
so for the neural networks, neural network model where we use lot more data, we need
Mhm.
GPUs. We need GPU instance, and those are also very expensive. So we have to be very careful. When you're not using it, switch it off. Like that's
Yes.
like it's a mandate. You have to do it.
But
We've
how do
also,
you manage this? Like how do you ensure that people kind of switch it off automatically? Like,
you don't. So what we have is, if the notebook is idle for X number of hours, shut it off.
okay, okay, so you have a time constraint after which if it's not working, you will set that up. Okay.
Right? That's fine for us, but we hope that people will do it before, right? Like,
Okay. Yeah.
yeah. So
Ideally, you would want to get to potentially the system where if you are running it, if it's idle, it automatically scales up, down, and ensures that it's
correct.
shut down.
Yeah,
So,
correct.
cool. Understood. And you mentioned about now trying to build a better version of SageMaker. So I'm curious to know about the plans there. Like, how do you take this build versus buy decision? Because there are a lot of ML platforms out in their market. Would love to hear that. As how do you decide that? And secondly, when you say better than SageMaker, what are the things that you really want to build better as well?
Correct. Right. So, see, this started off as an experiment, as an R&D experiment where we saw whether we can do it or not. And now that we have a big team, we can build some of these things in house, right? That was one important feature. And because we had experimented with our own virtual system where we had notebook and we had a lot of connectors and we had other sort of features, some of them was already part of it, right? Some of the things that SageMaker offered, we already had it. What we didn't have was distributed compute, which SageMaker offers, right? And that addition to our existing system could just give us the right solution.
Okay.
So
Interesting.
that wasn't that big of a piece to add. So that's what we were planning to do it, like on the existing virtual machine where you're running a PyConsole, just add distributed computing to it. It will
Sure.
just be much easier.
And how about the user access control management and all? Like that's already built into the system.
So different IAM roles for different people. We also have like a child account, which is just for our data team, and also that we can manage our cost internally and everything. That is not everything is built in. Like I said, we're still experimenting, we're still working on it, but we don't know like this is the level of access or this is the level of preferred accesses. Like even now when we work with very sensitive data, right, your bureau data
Mhm.
and stuff like that, if you're not working on it, you cannot access those data point, PII data and all of that, right? So
Yeah,
some level is already there, but we do have a lot more work to do on it.
got it. Understood.
Yeah. And
Understood.
as fintech firms, you have to be very careful about data because you're audited, right? You're audited by
Sure,
RBI firms and all
sure.
of that. So those are sort of ingrained. Who accesses what data is, yeah, very, very important.
Got it. Interesting. So, say when we talk from a fintech firm's perspective, right? Like you'll need a lot of customization around accessibility of the data, as you mentioned, who accesses it. Um, so, like, I wanted to understand that with given that, uh, is that a constraint that leads you to not adopting an external platform, or was it that because you had the system built out and there's only like the distributed computing layer that needs to be added? Is that the reason? Like, suppose if you had
Second
not
one,
built this out.
no, second one is really the reason. Uh, First one, we do have some third party vendors, right? It's not that. Our
Got
aim is definitely to have, as we scale, right? When we were smaller, have more third party vendor. But as we are scaling, as the team is getting bigger, if you can do it in house, why not? That's the question, right?
Got it.
For the SageMaker specific option, second one was it. Like it was just that missing piece. Add it to it, you'll get a lot more sort of flexibility and capability. Do it, right? And distributed computing is something that we have already tried in some systems, like we use Dask and all of that.
Got
Right.
it.
So yeah. So in this case, it was that. But yeah, overall, what we've seen, especially now that the market situation has changed, right? It's more like
Mhm.
build it in house rather than go outside. Do it in house.
Okay. It's from a cost perspective when you say the market situation. Okay. Understood. Let's go into a little bit about the decision making factors that matter to you from an ROI perspective, right? Like you mentioned earlier about, say, for the real time model, you mentioned about the latency, right? Like 70 milliseconds. What are other things that really matter to you when you kind of deploy these models, like from a cost perspective, the scale perspective, maybe other things that matter? Would love to hear about that, and how does that then flow into the data science process?
Right. So, so most important, if it's a real time system, because we don't directly talk with, merchant systems or user interfacing systems, right? We talk with our internal team, our front end teams and other teams, engineering teams,
Got it.
right? So there is this very strict SLA we have to adhere to, like no
Hmm.
questions asked, right? So SLA is definitely important for real time systems. Then our load is not distributed uniformly, right? Like true for almost every company. So there are specific peak hours where the load can be really high, like 20,000 RPM higher, right?
I see.
That load at 70 milliseconds, run a neural network model, which is not just using the current payload, but also combining historical payload, was not an
Hmm.
easy problem to solve, right? So yeah, so that was one very interesting project for us. Um, then apart from that, just when it comes to data science model, right? Like you don't create a model just because it's fancy thing to do, right? You create it
Yeah.
for an actual business impact, right? So
Yeah.
the way we do it is when we are training the model, when we are testing it, we come up with these metrics like at this particular threshold, this is, let's say it's a fraud model that you're building, this is the amount of fraud that you're going to stop, and this is the amount of good users that you're going to also impact,
Hmm.
right?
Hmm.
And you put
Yeah.
it at all thresholds to see the money saved, your good money which is going to burn out, you're not going to allow, right? And then you let your risk team and your CFO take a call as to what point they are comfortable, what cost they are ready to take, right? And at the back end we also share like, okay, this particular model, this is the amount of DynamoDB writes and reads, this is the amount of other cost that we expect. Like for example, when you build the network model, what's a fixed cost, what's the monthly cost that I'm expecting, so that you have a sense of
Okay.
you are saving this much money at this cost. Like that business metric has to be tied in.
Got it. Interesting. I would love to dive maybe a little bit into the load related project. What were some of the constraints that you saw, and how did you actually solve for it through the entire process? That's super interesting.
Yeah, no, that project went for long. And when we started off, we were like, okay, I know this is our constraint, but let's not take initially 70 RPM. Let's get it first. Let's solve for the problem of how do we merge the current payload with the historical data.
Mhm.
And then let's look at the other problems. So we broke it down that way. Again, technically, because it's not me who was involved, it's my data engineering team who worked
Sure.
so hard on this problem. So the
Sure.
technical details I cannot, but we I think there were a couple of things that we did R&D on, we tested it on, and finally we picked a flink. Like this is working out for us, right? So yeah.
Interesting. Got it. Cool. Amazing. Sika, you mentioned about the use cases initially. I'm just trying to reconcile in my head as well. When you talk about the collections, right, like data science impacting collection. So how do you feed that data back into your credit underwriting? Is there like segmentation of users? Like, because suppose you see a particular type of user that's actually not doing the collections, that's not actually paying back, then how does it circle back to affect a model that's for credit underwriting? Maybe it will be great to understand that like use case as well a little bit.
Yeah, I mean, definitely you have to do that feedback loop, right? So that goes on when we retrain the model. You retrain the model on the latest data that you have. And there is when you, so my collections team uses certain tools to call our customers. That data is also brought back. We have data pipelines to bring back that data. So they tag a user that, hey, he didn't pay because of this particular reason or this, and they have drop downs to do that. So it's not
Got
like
it.
we're doing text mining there, right? We have a
Sure.
separate product, test mining, which is on support tickets. We have recently started, but that's different. But here it's more like categorical data that's coming in for you and you
Mm.
generate that data. Now you have a pipeline which is there. You have it in your databases. So all you're doing essentially is when you're retraining, you're just refreshing with the latest data. And when
Got
we
it.
see a drift in terms of, let's say, this particular band that I shared, that, okay, this is the score, and the score, I expect this level of defaults, but that
Mhm.
level of default has changed, right? That's when you go deep dive and say, okay, do I need to refresh my model or do I need a new version of the model? So I'll restart on the feature engineering and everything again.
Okay. Okay. Got it. Cool. You mentioned about customer support. Like, would love to know about with the whole talk around LLMs coming in. What
Yeah.
is there anything you plan on that side to kind of use it for customer support? Is there any investment you are making, and how do you foresee doing it? Like doing it in house using open source APIs. So, would love to hear a little bit there.
And definitely an interesting area. I mean, we're all very, very interested with these new developments. Uh, right now, we're not doing anything with large language models,
Mhm.
but that doesn't mean we'll not do it. Like we'll figure it out. We'll see. Right now, what we are working on is more around prioritization of supports. Right. For example, this is a very premium customer of yours, and the kind of ticket they have raised. Versus someone who's raised a request for just information or FAQ, right? And we get so many requests. So how do you prioritize that? What is the SLA on some of the most critical issue versus some that can, you can even respond in chat back or send a message rather than get a call back from customer support. So these are the usual ones that we are working on right now. But like I said, I definitely foresee a lot of interesting use cases, right? How do you use some of these models in your chatbot, right? We have a chatbot which is not in house right now. Um, but one very important use case would be seeing how do you get that integrated, right? And there would be multiple use cases, I'm pretty sure of it, as we expand on the support vertical.
Sure. Great. I think good to cover the use cases and the stack side. Wanted to maybe hear a little bit about your thoughts on as the ML operationalization space in itself matures and
Hmm.
companies kind of have more use cases of ML. Where do you see the transition from, say, the build versus buy thing transitioning, and what will actually enable companies to invest more to maybe potentially procure something using a platform versus say buying it and building it internally? What are the decision making factors that go there in general, maybe not necessarily very specific? And yeah, I mean, how do you kind of think of the ROI from buying versus building then? What would
Sure.
then just, yeah.
Yeah, no, this is a very important question actually. When I think, and I'll tell you from my perspective, right, like the buy versus build thing, right? One, when we go out, especially when it comes to, ML systems or ML ops systems, right? One of the biggest concerns is if it's a, if it's a product which is very generalized, will it work very well with my systems, with my data sets, right? The way our data is sort of built in. And if I am putting in effort at my end to have engineers to integrate and sort of um, have customizations built on that product, I
Right.
might as well have those engineers work on building that product from scratch, right?
Got it.
So because you will always have customizations, not all data sets is different, right?
Yeah.
So how do you balance that, right?
Hmm.
For a small company, especially in India, especially now when we are more cost conscious, I think how the cost of outsourcing versus building it in house, how different they are, that would be a very big factor for sure, right? And
Got
then the effort of the team to maintain those systems or to enhance those systems is also a factor, right? If I have to continue to put three engineers there,
it.
I
Sure.
will question whether I can use those three engineers to sort of build it in house.
Absolutely. Also, would love to hear from the developer productivity angle, right? You touched two parts. One is probably in terms of the flexibility of the system to be able to integrate easily without involving engineers. At the same level, having the right abstraction, so there is
Yeah,
flexibility to also build on top. And the
correct.
second part relates to the cost. I would love to hear like where do you see the developer productivity angle here in terms of the speed at which say the data science folks can actually build models. So would love to hear a little bit around that as well.
Yeah, no, for sure we need to improve our productivity level. Like it takes for smaller companies like ours, which doesn't have pipelines built in, which doesn't have MLOps systems and all of these processes and systems built in. The time to start the project and go live is pretty high, right? Like
Okay.
easily 2 to 3 months, easily,
Got it.
bare minimum, if not more,
Okay.
right?
Got it.
How do I make it shorter? Because if you see the development time for models is becoming shorter, right? Most of your libraries are available, like scikit-learn would do most of your
Hmm.
training. It's not big deal to train a model, right?
Hmm.
So the time goes in setting up those pipelines, the validation test and all of that, fetching your data, cleaning your data, all of it, right? Like cleaning is still something which is huge time taking thing.
Okay. Interesting.
And then the deployment process. It's not like when you're deploying, let's say, a new feature on your app, the process
Hmm.
is still more stable. How you find bugs, how you do QA on it, right? That's very, very, how should I say it? It's very, the processes are very standardized, which is not the case in ML systems, right? To find bugs in a model is still hard, right? I mean, if somebody hard coded a where clause in it or some sort of, instead of greater than, they put equal to sign or something like that,
Hmm.
right? If you're not monitoring your data that is going in and data that is going out, those
Right.
bugs can happen all the time. We need standardization on that. So if there are systems available which is making a model development as seamless as a software development, making that process, that will
Hmm.
definitely help.
Very
Because it's right
interesting.
now black box to everyone, right? Like, I mean, and it's a fair question when business team asks you, hey, why was this person allowed versus this not allowed, right? And you need to answer that. You need to have that sort of feedback loop.
Got it. You bring up a very interesting point, like making ML's deployment probably as simple as
Correct.
software deployment.
Correct,
Uh,
correct. It's not, and it's black box for a lot of engineers. Even ML engineers who are deploying it who's not worked on the model. It's like, okay, you need this data. I'll help you set up this pipeline. I'll help you deploy it. What's like, is it real time? Is it batch? Okay, fine, I'm done with it. What you've built is a black box for me. You just need some input parameters and you get output parameters out of it. That's it.
yeah, versus in software where the person who is writing the code is probably taking it to the next level. So
Correct.
interesting. Yeah, this is one thing that been hearing quite a bit, like where a lot of the leaders in the data science they want the data scientists to be also ingrained into the engineering principles. I would love to hear
Absolutely.
maybe your thoughts around that, like especially when a lot of these data scientists come from statistical backgrounds and probably they are very good on the statistics side, but not really on the engineering side. So
Software development. Yes, we face that, and like I said, like batch systems, we would want our data scientists to deploy everything, right? And even filters. So sometimes we realize like good coding practices, because it's not ingrained, you will find there's a filter, like one bug which was like, in a filter you're doing a db call and you're running 5 filters, and for all of them you're doing db call again and again. Like you could just have just done it, cache the information, it would reduce your SLA, right? And the love for pandas, right? Like
Yeah.
in a real time system, if you're using pandas, which is slowing you down, right? Like
Yeah, sure.
it's just very hard to get them out of it, right? So those things which come very seamlessly to a software engineer is not ingrained in a data scientist, even though we push them and we try to get it. But I do know that you need ML engineers to deploy it, because it's not their core. They're more focused on, hey, how do I make the PR curves better, or because that's their core expertise, that's what they have learned. But I think in order to be a good data scientist, you need to be a good software engineer for sure.
Got it. Amazing. I think that's a great conversation. Last question before we kind of end it is for the fintech companies that are coming across the globe. Simpl has invested very early in ML. Would love to hear maybe any 2-3 cents from you as to what these companies should do around the ML journey and what they can do to make this faster. Suppose you took X months, how can they even make it faster and see potential faster business impact?
Right. So when we start, like, and it's such a wide, it's such a like the fintech companies can be small size, big size, right? Like it's such a wide variety that I don't think so I can have one answer for every one of them, right? It depends on where they are in their journey, how much business or size they're catering to. Maybe the number of users they are catering to is small, but each of them is a big ticket size user to them. They
Sure.
might not need to spend or invest so much into building systems which are, because you're getting a lot of scale, a lot of users hitting you. They might not need to invest. Maybe batch systems work very well for them, right?
Sure.
So at the end of the day, what is the business impact that you want will decide what kind of systems you have, right? But it always is useful to invest into monitoring, because at the end of the day, you are going to miss out on business if you make wrong decisions.
Fair
So
enough.
monitoring, I think, has to be critical.
Amazing. Got it. So I think it's ultimately like how do you tie down business impact and then decide
Absolutely,
on.
absolutely. Yeah, yeah. You might need simple rules. Like, I mean, fintech lending is probably one of the oldest industry. I mean, it has always been around even before engineering was,
Yeah,
right? So you might not need sophisticated systems.
sure. Cool. Amazing, Sika. Great chatting to you. Any questions you have for me? Otherwise, it was great having you with us.
No, it was fun talking to you. I really enjoyed our conversations. Thank you, Anurag.
Thanks a lot, Sika.
Okay, bye.